Hello everyone, I'm Hanan Ahmad. This is my big data assignment demonstration. The task is to build a Kafka-based system that produces and consumes order messages using Avro serialization with a running average of prices, retry logic for temporary failures, a dead letter queue for permanently failed messages. Correct. All the codes are in this repository, the folder. Here, the main files are docker compose.yaml. This is to run Kafka locally. And others are the order AVSC and DLQ AVSC, this for the Avro schemas. And another important file is producer.py, which generates the orders, and consumer.py. This processes them and does retries and averages and then sends failed ones to the DLQ. And another file is the readdlq.py, which this will reads from the DLQ topic. First, I'm going to start the local Kafka stack using Docker Compose. Yeah, here this will brings up to the containers, the zookeeper, Kafka 1 and schema registry. You can see these containers in the Docker desktop. Here these three containers are running under Kafka orders. Here we can see the Kafka and zookeeper containers are running and the broker is listening on port 1992. Next, I'm going to start the consumer process. It subscribes to the orders topic, deserializes Avro messages, maintains running averages of prices, implements retry logic for temporary failures, and sends permanently failed messages to a dead letter queue. Topic called that the orders DLQ. Now I'm going to check that one here. Now I started the producer. It continuously generates random orders with an order ID, a product name, and a random price. Each order is serialized using the order AVSC schema and sent as an Avro-encoded message to the orders Kafka topic. Here in the consumer output, each time an order is received, it is decentralized from Avro and processed. For each order, here I print the product, the price, the overall running average, price across all orders, and per product average. This satisfies the real-time aggregation of the prices which required for our assignment. Here you can see there are some errors in the terminal. Here this is a temporary error processing, and here you can see a permanent error simulated. When the temporary error occurs, it retries the same message up to 3 times with a small backoff between attempts. You can see here a temporary error on an order followed by successful processing on a later attempt. This demonstrates the retry logic for transient failures. And also, if a permanent error occurs or if all retries are exhausted, the consumer sends the original order to the dead letter queue. Now I'm going to run another terminal. Here I'm running the read DLQ. This will subscribes to the order DLQ topic and prints any DLQ messages it receives. To clearly show the dead letter queue behavior, I also have a small helper script. Here, the inject DLQ file. This will inject a test DLQ message into the orders DLQ topic. In normal operation, the main consumer publishes real failed orders here. But for the demo, this guarantees we see at least one record. Now I'm going to inject that one. Now the DLQ consumer reads from the order DLQ and decodes the message using DLQ AVSC schema. Here we can see the failed orders here. This is the receivers. This demonstrates the dead letter queue for permanently failed messages as requested in the assignment here. So this is the system I have created in according to uh, satisfy the assignment requirement. To summarize, this system uses Avro serialization for order messages defined in order AVSC. And also it maintains a real-time running average of prices in the consumer, and it implements retry logic for temporary errors with a maximum of 3 items. And also it sends permanent failed messages to an order DLQ, the dead letter queue, and can read them using the read DLQ script, and is packaged as a Git repository for submission, and the link of the Git repository is added to the submission folder. This concludes my demonstration. Thank you very much.